The mean is one of our tools to measure center for a data set. There are three tools that we use to find the central tendency: mean, median, and mode. When you hear the term central tendency or center, think of typical. What is a typical number in the data set that can describe the data set? Each central tendency has its advantages and disadvantages. The mean is used to calculate your grades, and in the animal data and voter data set, we're going to see how it is what is considered typical. Before we go into the mean, let's look at the contract for Pirate. So the mean contract has the title mean. It takes in a table, and it takes in a column as a string, and it outputs a number. So let's practice with the animal data set. So I want to find the average, the mean of the animals data set for the weight of the animals. So we see that about 41 pounds is the typical weight of the animals in the data set. But here's the thing about data science. We don't just use one tool, right? Even with the central tendency, if we pick just one of the tools, we might list all of the tools. And also what we could do too is show data displays. So we're going to look at the pounds, and we're going to also look at how they're spread out. So remember, the mean was 41, right? But when I look at the animal data set, it is clear that the typical number is actually less than 10. Like if we said 41, and more than half of the animals weigh less than 10 pounds, it feels like a bit of a disservice. And the reason for that is when we look at the shape of this histogram, it's skewed to the right because of these two values. And when we have a skew, that means we have the potential of outliers. Outliers are values that are really large or really small that skew the mean, skew the central tendency of the mean. And I like to tell my students is they make a liar out of the mean. So when we have outliers like this, we shouldn't use the mean. Let's look at another example. For the voter data table, right, we want to see what's the average percentage of voters who are white. So we're going to take mean, we're going to take the voters data table, and we're going to look at white voters. On average, according to this data, it's 52% come out and vote. Let's see what our histogram looks like for white voters. And if it's 51, let's go by 15. So we see here that actually I don't like this. It's not. We need more bins. Remember, typically we like 5 to 10 bins. So let's go by tens. All right, a little better. Let's just see if we zoom. So what we're doing is we're zooming in a little bit every time just to see. Okay. So we see that we have between 40 and 45%, and then we see here between 55 and 60, we have another peak. So this is a bimodal data set, right? So what this tells us is that the mean, 51, is right in the middle. And would you use it for this data set? Maybe. I mean, I don't think there's anything against using the mean for a bimodal data set, as long as you show the data, the display, so people know that, there are times where 40 to 45% of white voters come out, and there are times where 55 to 60% of white voters come out, right? So here I don't think you can't say that 51 is a liar like we did for the animal data set, but we can say that there is that there is more to the story than just a number. And that's important, right? That when we just use one number to describe something, it can be a little dangerous. Now, in our next lesson, we're going to learn about what tool we should use when the mean is not appropriate. And also, how can we tell if there is actual outliers in our data set and that we should avoid using the mean? Until then, have a great day.